All right, this is going to be 2.2 part 2, and we're going to look at rational equations. Okay, so a rational equation is an equation that has a rational, aka fraction, expression for one or more terms. There must be a variable in the denominator of at least one of the terms. Okay, we just dealt with simplifying rational expressions in our previous section. So that we've got, we're going to have multiple rational expressions and an equal sign involved. That's what a rational equation is. So steps for solving. So we are going to look at restrictions on the variable this time. So step 1 is going to be to identify restrictions. Restrictions on the variable. And that's going to be any number that causes the denominator to equal 0. Right? Because you can't divide by 0. So any number that would cause you to divide by 0 will be restricted from the variable. Step 2, find the least common denominator. Step 3, multiply the whole equation by the LCD and simplify. So at that point, there should be no denominators remaining. Once you multiply by the LCD, there should be no denominators remaining in the equation. So then you can just solve the resulting linear equation. And then the last step, just check that your solution does not match a restriction. Because let's say the number 5 is restricted from the domain, but my solution is 5, then that 5 cannot be a solution. So then you would have no solutions. Okay, so your solution cannot match one of the restrictions. All right, so let's try this first example. Identify the restrictions. So what would cause these denominators to equal 0? Well, what if x equals 0? 2 times 0 is 0, so then you would be dividing by 0. 3 times 0 is 0, we can't divide by 0, so your restriction there is that x cannot equal 0. The least common denominator, so you're just thinking, what is the least common multiple of 2, 3, and 3? That would be 6. And then we need to have that x. Okay, so now we're moving to step 3. Multiply the whole equation by the LCD and simplify. So we're going to multiply this side by 6x and this side by 6x. So 6x times 7 is 42x. Just multiplying it by the numerator. 5 times 6x is 30x. And then 22 times the 6 gives me 132x. Great. So now how is that denominator going to disappear? So after you simplify all three of these, 42 divided by 2, 21. X divided by x goes away. 30 divided by 3, x divided by x goes away. And then 132 divided by 3, that's going to be 44. All right, so once you simplify all of those, you see the denominators disappeared. And of course, you could think about that another way. If when you're distributing this and multiplying, if you wanted to do 6 divided by 2 is 3, and x divided by x goes away. And so then you would just have 3 times 7 is 21. 6 divided by 3 is 2. 2 times 5 is 10. Okay, so if you're able to do that in your head, go for it. Otherwise, just multiply by the numerator. Multiply by the numerator and then reduce the fraction. Okay, so continuing on, 21 minus 10 gives me 11. And then dividing by 44, I get x equals 1/4. Okay, check to see that that solution does not match one of your restrictions, and it does not, so that is the solution to the equation. All right, try to answer this question below. If a solution matches a restriction, it cannot be a solution. Why? Okay, so we should be thinking if my solution is one of the restrictions, then that would mean that I'm going to be dividing by 0 when I plug that number back in. I can't divide by 0, so that would be an invalid solution. So why can it not be a solution? Oops. Because it would cause division by 0 when plugged into the original equation. Okay, so that's why. That's why your solution cannot be one of your restrictions. All right, next page. Okay, so let's practice solving a few more. And if you're feeling like you're getting the hang of it, at any point feel free to pause the video and just push play to check your answer. All right, so number 9. Step 1, get those restrictions. All right, so what would cause the denominator to equal 0 here? Again, that's going to be just 0 because anything times 0 is 0. So plugging in 0 in either of those places. So x cannot equal 0. Okay, now let's get our least common denominator. So here that's going to be 4x. So we'll multiply both sides of the equation by 4x. Okay, I'm going to do it the other way this time. So you can just go ahead and multiply the numerators and then simplify, but actually the more efficient way is to go ahead and reduce that with each denominator as you go, and then multiply what's left. So here's what that would look like. 4x divided by 2x is 2. So now I just multiply -5 times 2, -10. 4x divided by 4x is 1, so that's actually just going to stay 3. On the other side, 4x divided by 4 is x. So we're going to multiply x by -7, -7x. Okay, now we don't have any simplifying to do and we can go ahead and solve the linear equation. Okay, if you had done it the other way, you would have multiplied 4x times -5 and got -20x on the top and then simplified that to get -10. 4x times 3 is 12x. 12x divided by 4x is 3. Okay, so either way, this is just the more efficient way. Okay, now solving. So -7 equals -7x. Dividing by -7, x equals 1. That does not match my restriction. So you're done. That's the solution. Number 10. Okay, so my restriction is going to be a little different here. So when it's not just 0, you're actually going to take these and set them equal to 0 and solve for x. So I would do 2x plus 1 And I actually do cannot equal 0 to remind me that it's a restriction. 2x plus 1 cannot equal 0 because that would cause me to divide by 0. So let's figure out what value of x would cause this to equal 0. Subtract the 1 and divide by 2. So x cannot equal negative 1/2. So that's one of our restrictions, negative 1 over 2. Okay, and then the other one, 3x plus 1 cannot equal 0. 3x cannot equal negative 1. X cannot equal negative 1/3. So negative 1/3 is your other restriction. All right, so those are our two restrictions. So you just set the denominators not equal to 0 and solve for x to get those restrictions. Now let's get our LCD, our least common denominator. And for this one, that's just going to be the product of both denominators. So 2x plus 1 times 3x plus 1. Okay, so we need both of our denominators to be that. So, we don't need them both to be that, I'm sorry. We need to multiply both sides of our equation by that. Okay, so if I multiply this side of the equation by 2x plus 1 times 3x plus 1, then notice the 2x plus 1 here and here are going to cancel, and I will be left with negative 3 times 3x plus 1. Okay, similar thing on the other side. If I multiply this by 2x plus 1 and 3x plus 1, then my 3x plus 1s are going to cancel, and I'm left with 4 times 2x plus 1. So notice actually what happened here is basically I just took this denominator and multiplied it times 4, took the 3x plus 1 and multiplied it times the negative 3. So actually, you don't have to do the whole LCD thing in this situation. So let's reverse. And here's what you can do. And the situation is you've just got one term on each side. Okay, so not like over here where I had a plus sign, I had multiple terms on the left-hand side. And on the previous problem, I also had multiple terms on the left-hand side. So if the equation is just one fraction equals another fraction, then you can simply cross multiply. So you're going to multiply negative 3 times 3x plus 1 and 4 times 2x plus 1. And that's exactly what I have down here. All right, so we'll distribute the negative 3. Now we can solve for x. Distribute that negative 3. I went ahead and moved my x's to one side and my constants to the other side. Now I'm dividing by negative 17, so negative 7 over 17. Does that match either of my restrictions? Nope. So that is the solution. All right, number 11. Okay, so this time we have multiple terms on the right-hand side, so we can't just cross multiply. We're going to get our restrictions first. So what causes the denominator to equal 0 here? So x minus 3 cannot equal 0, which means x cannot equal 3. Okay, now let's multiply both sides by our LCD. Your LCD here is 2 times x minus 3. Just multiplying both of our unique denominators here. Okay, so I'm going to multiply both sides by 2 times x minus 3. So this side, 2 times x minus 3. This side, oh, no room, 2 times x minus 3. Okay, so on the left-hand side, notice that x minus 3's are going to cancel, and I'm going to be left with 2x. On the right-hand side, distributing this to both, my x minus 3's are going to cancel on the first one. X minus 3 divided by x minus 3, but I'm going to have a 5 times 2, so that's 10. On the second one, the 2's are going to cancel, the 2 that I'm multiplying, and then there's a 2 in the denominator, so those 2's are going to cancel. So you're just left with x minus 3. Make sure you put that in parentheses because you need to distribute the negative right here. The minus needs to be distributed. All right, now let's solve this linear equation. 2x equals 10 minus x plus 3. Adding that x to the other side and combining like terms. So x equals 13 over 3, which is not one of my restrictions, so that is the solution. All right, number 12. What is the LCD here? Well, let's factor this denominator first. X plus, not 2, x plus 1, x minus 1, okay? So let's get our restrictions. So what would cause the denominator to equal 0? It's going to be -1 and +1. So x cannot equal 1 or -1, plus or minus 1. Now our LCD is going to be at x plus 1 times x minus 1, which is just the x squared minus 1 that you see there. But I'm going to go ahead and actually multiply by both of those factors so that we're sure to see what cancels. So x plus 1, x minus 1. That's what you're multiplying by on both sides. Okay, so I'm going to multiply both sides of this equation by x plus 1 times x minus 1. Okay, on the left-hand side, if I distribute both of those to the first rational expression, the x plus 1's are going to cancel, and I will be left with 2 times x minus 1. And to the second one, the x minus 1's are going to cancel, and you'll be left with minus x plus 1. Okay, on the second one, multiplying by x plus 1 times x minus 1, they're both going to cancel because they're both in the denominator there. So you're left with just 2x. Okay, now we'll distribute. So 2x minus 2 minus x minus 1 equals 2x. Combine like terms on the left-hand side. X minus 3 equals 2x. I'm going to subtract that x to the other side. -3 equals x, or just x equals -3. That does not match either of my restrictions, so that's the solution to the equation. I failed to put one in here where your solution matches the restrictions, but I promise it does happen. Okay, we're actually going to finish off this page, just going to look at slope, so we're a little bit prepared for our notes tomorrow. So just looking at calculating slope, which you have definitely seen a few times before. All right, so the slope of the line through points x1, y1, and x2, y2 is given by the following. M equals rise over run. So I wrote it a couple different ways to think about slope. Rise over run, which is the change in y over the change in x. That's what this delta means. Change. So the change in y over the change in x. Or you could just say y2 minus y1 over x2 minus x1, where delta x cannot equal 0, right? We can't have x2 minus x1 equals 0 because we can't divide by 0. All right, so let's just try this a couple of times. Find the slope of the line through the given points. M equals y2 minus y1, so you can label these if you need to. Oops, not like that. Okay, so now the order actually doesn't matter. I could have labeled this just as easily x2, y2, x1, y1. The order does not matter as long as you keep the coordinates of the same point together. Okay, so we're going to plug those in. y2 minus y1, that's going to be -9 minus 2. x2 minus x1 is 7 minus -6. So that's -11 over 13. Excellent. Let's try it again. Do it on your own if you are ready. I'm sure you are. Okay, so 4 minus -8, -3 minus 3. 12 over -6, which is -2. All right, so just a quick little recap over calculating slope. That's it for our notes today. We will finish these notes tomorrow.